Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Level 23, the cylinder is subjected to a load as a weight W if the coefficient of rolling resistance for the cylinder's top and bottom surfaces are B sub A and B sub B respectively, show that a horizontal force having a magnitude P equals W over 2R, quantity B sub A plus B sub B is required to move the load and thereby roll the cylinder forward. Neglect the weight of the cylinder. So for the solution, let's have the free body diagram of the upper part, then free body diagram of the lower part. Remember, the principle is we have to locate the point where the reaction or the resultant of the load and the friction meet or intersect with the wheel's surface, and we sum up moment there. So for the upper part, this is R sub A, and we call this distance the coefficient of rolling resistance B sub A as shown. Then let's have the angle here, which is P sub KA. That's the angle. So R sub A cosine of P sub KA summation forces Y equals 0. So R sub A cosine of P sub KA, the vertical component of RA minus W equals 0. So that means R sub A cosine of P sub KA equals W. Likewise, summation forces horizontal equals 0. So R sub A sine of P sub KA minus P equals 0 or equals P. So that's the value of P. Then we transmit these values here, and let's draw the free body diagram of the wheel and the lower part. So RB would be to the left, so the point of intersection of reaction on the bottom portion is just to the left of the lowest point, so that's R sub B. Then we have the radial line. The angle that the radial line makes with the vertical is the angle of friction P sub KB as shown. Then this is B sub B. Then take note that P and W are already in this uh, already set up. Then we have the moment arm of P, which is this part is R cosine of P sub KA accurately. Then this moment arm is R times P sub KB. So the total moment arm of P about this point here is equal to R quantity cosine of P sub KA plus cosine of P sub KB. So that's the moment arm if we want the accurate derivation. So summation moment about this point here equals 0. So P times quantity R times quantity cosine of P sub KA plus P sub cosine of P sub KB equals the moment of W, which is W times quantity B sub A plus B sub B. So from there, we can now derive P accurately. It is equal to W times quantity B sub A plus B sub B over R quantity cosine of P sub KA plus cosine P sub KB. So that's the accurate formula for P. Now for the approximate formula for P, if the angles P sub KA, P sub KB are close to 0 or very small, then their cosines would be almost equal to 1. So we simply set this to 1. This one is also 1 for approximate derivation or values of cosine of P sub KA, cosine of P sub KB, noting or assuming that these angles are very small, which is the usual value. This angle of uh, kinetic friction normally is small after converting this coefficient of rolling resistance in terms of these angles, or after computing for these angles. So 1 plus 1 is 2, so that's why we have this formula here, but that's an approximate formula. But the approximate formula for this problem would be sufficient enough to deal with problems on rolling resistance. So P equals W over 2R quantity B sub A plus B sub B. Uh, Take note, that's an approximate value, but when the angles of kinetic friction are close to zero, then they will have almost the same results. Level 24, let's have the applications or verification of the formulas we derive in level 23. Then let's apply it in this problem here. A 900 kilogram machine base is rolled along a concrete floor using a series of steel pipes with outside diameters of 100 mm. Knowing that the coefficient of rolling resistance is 0.5 mm between the pipes and the base and 1.25 mm between the pipes and the concrete floor, determine the magnitude of the force P required to slowly move the base along the floor. Part A accurately and Part B approximately. So if you can recall from level 23 problem, we derived accurate formula for P required to slowly move the base along the floor, to slowly move the body along the floors and supported with wheels here. So the formula is W times quantity B sub A plus B sub B all over R times quantity cosine of P sub Ka plus cosine of P sub Kb. So for the solution, let's have the formula first from level 23, W B, quantity B A plus B sub B over R quantity cosine of P sub Ka plus cosine of P sub Kb, where sine of P sub Ka is equal to coefficient of rolling resistance on the upper part of the steel pipes over radius of the pipe, which is 50 mm. So sine of P sub Ka equals 0.5 B sub A over R. So sine of P sub Kb equals B sub B over R. Sine P sub Ka equals 0.5 mm over 50 mm, half of 100 mm. Sine P sub Kb equals 1.25 mm B sub B over 50 mm. So solving for these angles, P sub Ka is 0.5730 degree, which is a very small angle. Likewise, P sub Kb is 1.4325 degrees, which is also a small angle, that their cosines would be very close to 1. So substitute into this equation where W is 900 times 9.81 and R is 0.05 meter. B sub A, or let's just express R in mm, B sub A, B sub B in mm, so that the force P is in newtons. So P is 900 times 9.81, quantity 0.5 plus 1.25 mm over 50 mm, quantity cosine of 0.573 degrees plus cosine of 1.4325 degrees. Solving for P using your calculator, P is 154.5 newtons. Likewise, for the approximate formula, we set cosine P sub Ka 1, cosine P sub Kb 1. So this is 2R. So the approximate formula is W, quantity Ba plus B sub B over 2R. And substituting, P is 900 times 9.81 over 2 times 50 mm, quantity 0.5 plus 1.25 mm. So the value of P is also 154.5 newtons. So that shows that this formula is correct even if it is an approximate formula, as long as the angles of kinetic friction would be very close to zero, like these values here. Level 25, determine the force P required to overcome rolling resistance and pull the 50-kilogram roller up the inclined plane with constant velocity. The coefficient of rolling resistance is B equals 15 mm. So remember the principle that we have to locate the point where the reaction between the wheel and the surface meet, and we draw the free body diagram and simply sum up moments about that point. So let's have the free body diagram. So for the solution, we have the wheel and the forces and the weights. Weight is 50 times 9.81 of the uh, this roller here. Then we have an inclined plane P, this P here, which makes an angle of 30 degrees with this incline parallel to this surface. So this is 30 degrees, 30 degrees. This is also 30 degrees as shown here. So this angle is also 30 degrees. Then if we draw the normal, then that angle is also 30 degrees. This is the point where the reaction between the wheel and the surface meet, and we'll call that point B. And the distance along the incline or parallel to the incline to that point B from this axis here is B, which is equal to 15 mm. Therefore, this distance, the moment arm of the forces along this incline, parallel to that incline there, would be square root of, to make it accurate, you can make it R, but let's make it accurate because 15 mm is considerable. Uh, it is square root of radius, square root of 300 square minus 15 square. So this distance, the moment arm of the forces parallel to this inclined plane or parallel or along this line is square root of 300 square minus 15 square, 299.625 mm. Then we sum up moments about B equals 0. So P cosine of 30 degrees times 299.625. That's the component in that direction. The component along this direction, the moment is also clockwise. So plus P sine of 30. This is P sine 30, the component of B. Then times 15 mm. Then the component of 50 times 9.81 is in this direction, it is counterclockwise. So minus 50 times 9.81 times 15, sorry, times cosine of 30 degrees times 15. The component of 50 times 9.81 along this axis is 50 times 9.81 cosine of 30. Then the component in that direction, in this direction, which produces counterclockwise moment is 50 times 9.81 sine of 30, and the moment arm is 299.625. So 50 times 9.81 sine of 30 degrees times 299.625 equals 0. So only P is unknown in this equation, solving for P using your calculator. So P is equal to 299.1 newtons. Level 26, a scooter is to be designed to roll down a 2% grade at a constant speed. Assuming that the coefficient of kinetic friction between the 25 mm diameter axles and the bearing is 0.1, determine the required diameter of the wheels. Include the rolling resistance of 1.25 mm between the wheels and the ground. So for the solution, the idea then is because the scooter rolls down with constant speed, it means that the weight tangent to the circle of friction and the reaction between the wheels and the ground must coincide, as shown in the figure. So this is the circle of friction, this is the radius of the wheel, axle radius R. The radius of the scooter, let's call that capital R sub S. This is the circle of friction of radius R sub F. Then the weight W is tangent to the circle of friction, and it should coincide with the point where the reaction between the outer surface of the scooter wheel and the ground meet. So this is point B supposedly, and the angle here, the grade is 2%, or tangent of the angle is 0.02. So this is the line normal to the incline. So this is the R sub F, project it downward. This is also the coefficient of rolling resistance B, and we have R sub F here. This is the line parallel to the inclined surface of the ground, and this is R sub F. And if we denote this as theta, the slope or the grade, then this is also theta, so that from the figure, sine of or sine or tangent of theta, as long as it is small, equals opposite over adjacent or opposite over hypotenuse. So let's call this R sub S, the radius of the scooter. So sine of P sub k is approximately equal to tangent of P sub k, because P sub k is expected to be very small, and it is equal to 0.1, and it is also equal to the radius of the circle of friction over the radius of the axle by principle. So it is equal to 0.1. So that means the value of the radius of the circle of friction is zero point 0.1 of R approximately. So R sub F is approximately 0.1 of R. Then tangent of theta is 0.02, and it is approximately equal to B plus R sub F over R sub S. Approximate. So from here, because B is 1.75 mm, R sub F is 0.1 of R, and R is 12.5 mm, radius of the axle, half of 25, so 0.02 is approximately 1.75 plus 0.1 of 12.5 over R sub S. From here, we can now compute R sub S, the radius of the scooter, and it is approximately 150 mm. Therefore, the diameter of the scooter is times 2 of this, 300 mm. So that's it for this problem. Level 27, determine the smallest horizontal force P that must be exerted on the 200-pound block to move it forward. The rollers each weigh 50 pounds, and the coefficient of rolling resistance at the top and bottom surfaces is B equals 0.3 inch. So this is the figure, and for our solution, let's have the free body diagram of a roller, and imagine that there are two rollers already, so that the 200-pound force should be the weight on the upper part. And imagine that there are two rulers, because there are really two rulers. So the principle is we have to locate the point on the ground where the outer surface of the wheel or roller and the ground uh, intersect, so that, or meet, so that that's the point where the reaction on the ground and the surface meet, and we sum up moments there. So we have the weight of, for the upper surface, weight of the block, then this distance is B sub A for the upper part, this is 0.3 inch, then that's the force P transmitted, then this is the center, this is P sub A, call that P sub A, then at the center we have the weight of the ruler, and since there are two rulers, that should be doubled later in our final calculations. Then this is point B, the point where the resultant between the ground and the surface of the ruler act. R sub B. The horizontal distance of that point from this vertical line is B sub B, and this angle is P sub B, and this is B sub B. Then we set the moment arm of P as accurately as we can. It is P times R of ruler cosine of P sub A. This is R of ruler cosine of P sub B as shown. So R of ruler cosine of P sub A, while this distance is R of ruler cosine of P sub B. So that's the moment arm of P. The moment arm of WB is B sub A plus B sub B. The moment arm of the weight of the ruler is B sub B. So R sub R is 1.25, radius of the ruler is 1.25 feet times 12 inches per foot to convert it to inches. So it is 15 inches. Then we sum up moment about B equals 0. So P times quantity R cosine of P sub A plus R sub R cosine of P sub B equals WB times or minus WB quantity B sub A plus B sub B minus WR times quantity. This WR here represents the total weight of rulers times quantity B sub B equals 0. So simplifying and deriving a formula for P is, by the way, R sub R cosine of P sub A equals R sub R cosine of P sub B, because the coefficient of rolling resistance at the top and bottom are equal. So it is square root of radius of the ruler 15 square minus B sub A square or B sub B square. Square root of 15 square minus 0.3 square is approximately equal to R sub R. Use your calculator there. So it is still 15 inches. So substitute in this equation P times R sub R plus R sub R, because cosine of P sub A times R sub R is just R sub R. R sub R cosine of P sub B is just R sub R also, after we verified it here. Then equals WB quantity B sub A plus B sub B plus WR times B sub B. So P therefore is equal to WB quantity B sub A plus B sub B plus WR times B sub B divided by 2 times R sub R. So we note that the total weight of rulers is 2 times 50 pounds. WB is 200 pounds. That's the total load on the 2 rulers, because we imagine there are 2 rulers here, because the given figure has 2 rulers indeed. So R sub R is 15 inches, B sub A equals B sub B 0.3 inch, and the weight of B is 200 pounds, WR is 2 times 50 pounds, B sub B is 0.3. So everything is given. So P is 200 times quantity 0.3 plus 0.3 plus 2 times 50 quantity 0.3 all over 2 times 15. Solving for P is equal to 5 pounds.